Good morning and welcome, ladies and gentlemen. My name is Wayne Burke. It gives me great pleasure to be bringing you the AI robotics and drone hacking Build, Hack, Detect, and Defend series. Let's jump straight in. We're going to be looking at a technical deep dive into sensors, flight controllers, some of the foundations of radio frequency, and UAV general communications. So we mean UAV, your unmanned aerial vehicle communication, your drones. And we're going to be looking at an array of different tools that you can use, from software to hardware to drone platforms. And an example of a aircraft that's typically used for racing, SpeedyBee Master 5 version 2. This is about a 5-inch drone, pretty powerful, very, very well made, manufactured drone. Obviously, looking at the specifications there, you can see pretty impressive breakdown of hardware. So what makes this very, very flexible is that it supports your Bluetooth BLE, so you can basically do your flight controller configuration there pretty effectively. So it makes tweaking your configuration in the field so much easier. And of course, it's very helpful if you have a laptop, dedicated machine for doing some of your cybersecurity research. We'll be talking somewhat about software-defined radios. You can use anything as cheap as your RTL SDR or some of the more expensive Lime, ETIS, HackRF, and so on. All right, so let's have a look at some of the drone hacking news and technologies. This is where Interpol carries out full-scale drone countermeasure exercise. And you can read more about the outcome of that. That was from September 2021. And we need to remember when we dealing with these drones that the batteries, the lithium batteries, are highly combustible. So you need to be very, very careful whenever dealing with LiPo batteries, where you're going to have specific LiPo battery storage bags. And of course, the other danger is the propellers. So when you're doing any engineering, when you set up your flight controller, as you'll see, you want to make sure you remove your propellers. Here was some of the news in the recent media. Russians installed a GPS jammer in Ukraine. The Ukrainians blew it up with a GPS guided bomb. Obviously, no pun intended there, right? So we've seen China to take hack-proof quantum satellite technology to new heights. Again, this is just bringing you up to speed. This is from the space.com website. And they've been doing this, as you can see, they launched way back in 2016, the first dedicated quantum communication satellite. Europe's also planning to launch a quantum encryption satellite. This is launching later on this year in 2024. And you can see more information from the Europe Space Agency, or your ESA. So Eagle 1 will spend 3 years in orbit testing some of the technologies needed for a new generation of secure communication. And again, you can see the URL for the web address to go and dive a bit deeper into that. So new technology, new tiny radar could detect movement in 1/100th of a width of the human hair. So that's the new millimeter wave radar tech. Now, whenever we look at flying drones, you need to be aware of some of the laws and regulations in your country. In the United States, you're looking at using the FAA, or Federal Aviation Administration, as well as your FCC for your communications. And you also have some of the additional local enforcement. So different states have got different rules. Now you can use a free app called Before You Fly. It's an FAA smartphone app. So that's going to obviously tell you if you're able to fly in the area. If you're too close to an airport, you're not going to be able to obviously fly there. And it will actually show you within a map. So where your no-fly zones are. And there you can see the controlled airspace versus caution, and then where you can actually fly where it's legal, where it's clear. Now, when it comes to drones, we're going to see a lot more incidents because there's a lot more of these birds up in the sky. So you've got your drone incident response framework from Interpol. That's very helpful to guide first responders and digital forensic practitioners. Excuse me. And so the purpose of Interpol was to obviously carry out a full-scale drone countermeasures exercise. And they had a support from a lot of the other country specifics, from Norway to other European states. And basically, each countermeasure was assessed and graded against specific criteria. And you'll be able to find out more information from their report. And you can see Interpol ran this across 194 member countries. So this was a huge operation, though. You just seen a few of the players that were involved there, or who actually organized these events. So we want to be more aware of operational courtesies, polite piloting. So obviously think about where you might be in an area where there's kids playing in a park. You don't want to go and upset the public there by flying your drone around near kids, as an example, without any guards. Obviously, it could be very dangerous when you got, depending on if it's a quadcopter or hexacopter, you're going to have multiple spinning knives effectively. And this was a really great video originally, long time ago right now, but you'll see a huge amount of amazing athletic flexibility in quadcopters. So Raffaello De Andrea, he's been doing a lot of this research from one of the main universities. So you can go and check out more. It was a TED.com presentation. So this is looking real quick into the configuration of the DJI Tello. And you can see there's a 14 core processor on board. It has collision detection, there's propeller protection, and it weighs just 80 grams. That's pretty impressive. Now you might be wondering why the Tello. The Tello is really designed for education institutions like schools and so forth. So basically, it gives you a huge amount of technology in a small form factor, very low cost, weight, lightweight, has an optical positioning system for better indoor stability. That's without a GPS. And it also uses Wi-Fi, where you can fly it with either using a Bluetooth remote control, or you can actually use your cell phone tethered to the Wi-Fi hotspot running on the Tello. And there you can see a look at some of the setups. Now, as I mentioned, SpeeDB used for a lot of racing activities. Well, this is the SpeeDB Adapter 3, where you can collaborate with the drone through your cell phone and Bluetooth. And you can see you can do wireless firmware flashing. It's got a black box analyzer. It's got its electronic speed controller flasher. So each motor is controlled by electronic speed controller. It's got a fast USB charger, and it supports 1 to 6 cells LiPo batteries. Now, when you look at the memory used in your UAV systems, this is obviously important where some systems are going to obviously store flight data. They may use a micro SD card. Cameras typically store different piece of information, and there's various different types of form factors used. So you have data interpretation is very manufacturer centric. Now onto your batteries. So of course, when you look at batteries, the lead acid battery, right, of the 19th century, you can see some of the real historical 1912 illustration of histories of your actual battery cells, where they would basically use like a glass jar with the various different types of the carbon, um, the porous pot, and then the terminal. So effectively, you're looking at your electrolyte composing of zinc, copper, and sometimes other elements. So at home, you might be used to alkaline, non-rechargeable, or NiCad, your rechargeable batteries. But lithium-based batteries really offer the highest capacity, and they can physically swell when charged and not discharged for storage properly. So very often they soften under depletion. Now, modern RC batteries are really capable of discharging 100 plus amps and very easy to catch fire. So this is why we mentioned your safety in drone batteries, LiPo batteries, otherwise as they're known. And onto the motors. So your motors, most commercial UAVs are brushless motors, and we'll be talking more about that. Like it was invented for the original floppy drives for computer systems. And so the brushless motors allow for fine-tuned rotational control with minimal running parts. They do require your ESC, your electronic speed controllers, to better manage and process your signals. So when you're looking at trying to fly and hover balanced, you got perhaps you're using a 4-motor quadcopter as an example. Each of those motors are going to be spinning at certain, speeds to ensure stability, like hovering. And there you can see a great diagram of your brushed DC motor versus your brushless DC motor. So your brushed direct current motors effectively use small brushes to apply the voltage across a dormant electromagnet. And so obviously a magnet produced when you've got electricity flowing. So it can be switched on and off. However, the more popular in bigger drones like racing drones and so on is the brushless motor, which typically uses 3 electromagnets instead of 1 and requires precision timing. This is why you need the electronic speed controller from an external device typically. And then you can see a breakdown of the Tello brushed motor, very small, but take a look at the top left there. The Tello motor lifespan is about 40 hours. So you can see the actual magnet, you can see the winding, you can see the magnet, right? So it's like one magnet. And then looking inside your brushless motor, so brushless motors has its sensor and assembly of silicone steel sheets and your windings, otherwise known as your coils. So you can actually see the multiple magnets there and the coil winding around each magnet. So it does not spin. So it's called a stator. And the surrounding stator is an assembly called a rotor. And that's effectively your magnet yoke and a circle of permanent magnets. So when you look at a single phase motor, when electricity is fed into the stator, the magnetic field that attracts and repels the magnets in the rotor which is what actually causes it to spin through 180 degrees. So to keep it spinning, the poles of the electromagnet are switched every 180 degrees, and that's how it's using the push-pull force. Now, another very important component is going to be your flight controller. Your flight controller are typically your ST Microelectronics STM32 family chipsets, which are found in everything that's controlling fundamental biomedical devices, in drone technologies, of course, extensively, IoT, OT, SCADA. So they are effectively the heart and the core of running. You can see the example on the bottom right there, the Pixhawk 2 Cube. That's actually showing you all of your various different types of ports that are used. So your telemetry ports, and we'll get into more of that in a minute. And so when you speak about the PID control algorithms, those are used to reduce the difference between an actual and requested position. So when you're looking at racing drones, you're constantly looking at fine-tuning your PID values, which you can do very easily through like that SpeedyBee flight controller. So your loop times are the enemy of your smooth flight, which is if you have your PID values untuned, you could experience an unstable flight. So remember, your flight controller is the central processing unit of your robot. It's effectively the brain of the aircraft. And there's an array of different sensors depending on obviously what types of flight controllers you're using. It's a circuit board with a range of sensors that are obviously going to be used to detect movement of the drone. And nearly all flight controllers have basic sensors such as your gyroscopes and your accelerometers, while some of your flight controllers will have more advanced sensors like your barometers for your barometric pressure sensors, as well as your magnetometer, your compass. Now, you might also plug in other peripherals like your LED light, sonar, LiDAR, GPS, and so on. And here's an example of some of the popular FPV race flight controllers. You can see the processors, the processor speed, and how do you collaborate and flash and configure it through how many UARTs on your flight controller. So it's effectively what pluggable ports you actually have available. Now, this is an example, a deep dive, looking at some of the older CC3D flight controllers. They were about like $10 or $15, but you can see the entire design of how it connects to your battery using your power distribution board. Each motor is controlled through an electronic speed controller. You may have a UBEC, a battery elimination circuit, a chip, basically it's a voltage regulator responsible for converting your LiPos to a lower voltage. So maybe you want to use a companion flight controller using a Raspberry Pi, which would obviously need 5 volts. So using 2 S cells would need to bring the voltage down from 7.4 volt down to 5 volts. And you can see some of the other peripherals such as satellite. So you're using your S-Bus, your I2C, or UART. And then your telemetry is where you're going to obviously collect that telemetry on a remote control or through a separate USB dongle on your laptop. And we're going to take a look at using different software now, like your Libre Pilot. So let's dive into that. So here's an example of Libre Pilot. Now this was much more powerful back in its day, but this is what we typically used when we wanted to set up a flight controller, some of the cheaper flight controllers in the past. And if you just go into, you can either follow through the vehicle setup wizard, And there you'll see how you can do everything from flashing your firmware. It will identify a board that's plugged in. Obviously, I can't go any further without plugging in the board. But essentially, if we go into the main configuration, you can see you got everything from your initial welcome screen to then actually using this as your flight controller, ground controller system. We've got all of your flight data. And then down to the configuration. So configuring your hardware, you'd essentially connect to the onboard flight controller, your vehicle setup. So you would go and specify what kind of form factor the airframe is, your remote control, your output, your motor outputs, and so on. So that's just open source free flight controller software. And then the very, very popular Betaflight, which is really what is mostly used nowadays for a lot of the racing drone competition. But it's a world, of controlling all different types of flight controllers. So there's a lot more support from industry sponsors. You can see the flight controller configuration there and the Betaflight's history there, where they originated from the original hardware days of Multi-Wii, which was an original port for the 32-bit. It was then called Baseflight. There's a new fork of Baseflight, which moved it into the name of Clean Flight. And then finally, as it's now called, Betaflight. So that's showing you the Betaflight interface. This is the latest version, 10.10 currently. And same as what you saw within Libre Pilot, you've got the ability to update your firmware on the drone. You can download a specific black box log viewer, and there's a ton of scripts that you can actually use. So you can take a look at the firmware where you can download it, and then your typical configuration. So you've got various different types of options, showing your firmware flasher component, and then your initial welcome screen. So once you obviously connect, there's nothing connected right now. Once you connect, you'll be able to configure and see the whole setup of the drone. So here was a little bit more of a technical description of the CC3D. Was showing you that it's an STM32 chipset with an ARM Cortex M4 at 210 MIPS. It's a range of built-in hardware modules that can be programmed, as we spoke about. And there you can see just an example of some of the ports, like your pulse width modulation versus your PPM for different receivers. And on that note, that's where we're going to be finishing off this first in the series of drone hacking, detecting, monitoring, defending workshop series. My name is Wayne Burke. It's given me great pleasure to deliver this event to you all. And we thank you for sharing your time with us. And we wish you the best of luck on your drone journey to cyber security skills and best practices. Take care, everybody.